If you have used Pandas, you know it's amazing for data analysis. Simple, powerful, and widely used. But there's a catch. As soon as your data gets large, Pandas can become painfully slow because it runs on just one CPU core. So even if you have a laptop with 8 cores or a server with dozens, most of that hardware just sits idle while Pandas slowly crunches through your data. You might find yourself waiting minutes for operations that should feel instant. That's exactly the problem Modin was created to solve. Modin helps you actually take advantage of all that hardware. It spreads your Pandas operations across every available CPU core, and if you need more power, it can even scale across multiple machines. The amazing part is you don't have to change your workflow. Usually it's just one line. Replace import pandas spd with import modin.pandas.spd. Under the hood, Modin uses engines like Ray, Dask, or Unidis to parallelize and distribute the work. So you get away more performance out of the same code. Let's jump into examples and see the speed difference. Alright, so as you can see on my screen, I have started a Jupyter notebook. All the code for this tutorial is available in this Jupyter notebook. I will include link to it into the description so you can follow along. At the beginning of the notebook, I have included a small description about what Modin is, and then there is an image of the architecture of the Modin. So as you can see, it's based on Ray, Dask, and Unidis. So those are the execution engines. Then there is a Modin Dataframe, and there is a Pandas API. Other than that, there is a SQLite API, which is experimental, and they are also planning the Modin API. So that's the architecture of Modin. Now in order to use Modin, you have to first install it. So you can simply install it using pip install command. And if you only install Modin, then you will have to install the Ray, Dask, or Unidist, one of the backend that Modin will use separately. Or if you want that Modin installs them as well, then you can install this command, pip install Modin all. This will install all these 3 backend, Ray, Dask, or Unidist. Now, as I said, that Modin is based on other backend frameworks, which are Ray, Dask, and Unidis. So by default, the framework is Ray, which will be used to distribute the workflow. But if you want to change the default, then you can do that in 2 ways. You can use the shell and set the environment variable over there, named Modin engine. And another way is to use the OS module of the Python, and you can set the environment variable Modin_engine with the name of the backend. Alright, so in the first cell, I have imported Modin.pandas as MPD and our original pandas as PD, and we will be performing operations using these two and compare their performance. Other than that, I have imported other useful modules like OS, garbage collection, and Ray, Dask, etc. I am setting the default environment variable Modin_engine with Ray backend because that's the one we will be using. And over here, I am initializing the Ray cluster. Calling this command ray.init will initialize the cluster on your local computer. So that way it will utilize all the cores of your computer. If you don't call it now over here, then whatever is the first command that you execute using Modin, that command will initialize this cluster. So it can take some time for the first command, but then it will be faster. So to avoid that, I have initialized the cluster beforehand. Alright, so now that the cluster is initialized, let's go ahead and compare the performance of Pandas and Modin. So in first section, we will compare the read files performance between Pandas and Modin. So I have downloaded a simple CSV file which is available from Modin website, and I have saved it on my local as taxi.csv after downloading, and that file is of nearly 200 MB. So it's not that big file, but it's enough for this tutorial. So first of all, I'm reading that file using read CSV command of our original Panda, and then I'm doing the same using Modin Pandas. And to record the time taken by the commands, I am using this cell command of the Jupyter notebook %% time. So it will it will record the time taken to execute whatever code is present in that cell. And we have only one line of code which is reading of the file. As you can see, Pandas takes nearly 3.42 seconds to read this CSV file, and for the same file, the Modin takes nearly 1.77 seconds. So that's just half of the time of what Pandas takes. So we are able to get 2x performance by simply replacing Pandas with Modin, and we haven't done any other changes. You can also analyze the dataset. So the dataset that we loaded has 21 columns, and there are 1.93 million rows in this dataset. So it's a big dataset, but not that big. Next, let's try to concate some data frames to create a big data frame. So for that, I have taken our original Pandas data frame, which had 1.93 million records. And from that, I am taking first 1 million records. And we are looping 25 times. So that will be the 25 Pandas data frame, each of 1 million rows. And then we are calling concat on it to concat all the 25 data frames of 1 million rows into one data frame. So this big Pandas DF will have 25 million records. And to perform that operation, the summing of all that 25 Pandas data frame, it took 1.26 seconds with Pandas. Whereas when I perform the same operation using Modin, as you can see using MPD, the same operation took 486 milliseconds. So that was almost 2.5x faster compared to the original Panda. And we were able to get that performance boost without any code change. Next, let's try a commonly used function to modify the columns data, which is apply function. So in our original data frame, there is a column named trip distance. And to there, I'm applying the round function. The Python round function will round the values. And that operation using the normal Panda took nearly 543 milliseconds. Whereas when I tried the same operation on Modin data frame, it took nearly 106 milliseconds. So this time we were able to get 5x performance using Modin. Next, I again tried one more example of the apply function. And this time there is a column name payment type in our original data frame, and it has 4 values 1, 2, 3, and 4. And inside of apply, I am simply mapping that values 1 to string first, 2 to second, third, and fourth. And that operation took nearly 245 milliseconds using our original Pandas, whereas same operation using Modin took nearly 100 milliseconds. So Modin again this time was 2.5x faster compared to our default Pandas. Next, let's try filtering data frame, one of the very commonly used operations on data frame. So what I tried over here, I tried to filter our original data frame where the payment type column has values 2. And as you can see with the default Pandas, it took 85.8 milliseconds, where with Modin, it took 37.5 milliseconds. So again, we were able to get nearly 2.5x performance using Modin. Next, let's go ahead and try to add a new column to our data frame. So we generally apply some operations on our existing columns and create a new column. So to create that example, I have taken a column payment type and I have applied a function lambda, which simply squares the values of that column. Now, these kind of operations are very common to create new columns. And as you can see with default Pandas, it took 473 milliseconds. As the same operation with Modin took nearly 101 milliseconds. So that was almost 4.7x speed up compared to our default Panda. Next, let's try to fill some NaNs. So I have a column in our data frame named congestion surcharge, and that column has some NaNs present in it, and I want to fill NaNs with -1. And this is also one of the most commonly performed Pandas operations. And with default Pandas, it took 21.6 milliseconds, which is faster. But Modin even took it to next level and it completed it in 13.9 milliseconds, so which is almost 2x speed up. So even basic operations like fill NaNs is speeding up using the Modin. Next, let's try sorting values, sorting our data frame row. This is also one of the commonly performed data frame operations. So I called the sort values by the column name payment type, just 4 values 1, 2, 3, 4, and I am simply trying to sort our data frame based on that. And with default pandas, it took for 249 milliseconds, whereas with Modin, it took 162 milliseconds. So it was able to speed up even sorting of data frame. Next, I tried one commonly used pandas function, which is to datetime. And if you have datetime data in some column and you want to convert it to the datetime format, you generally use this function. This is also very commonly used. So we have a column named datetime, and I want to convert it to datetime. By default, it's in object format. So with default pandas, it took nearly 330 milliseconds. Whereas when I tried the same operation using Modin, it took 20 milliseconds. So this time the speed up was too much. It was almost 10x or even more than 10x, 15x speed up. And now in the last section, I want to talk about that why Modin may not always work. So during my experimentation, sometimes Modin was not speeding up. So as you can see, this example of summing of two column values. So this one fair amount is again float and tip amount is float. So I am summing up that values to determine the final amount. And that operation with pandas took 4.27 milliseconds. But same operation with Modin took 26 milliseconds. So in your workflow, there will be some code which might not speed up using Modin because it might not be suitable for parallel computing. So that code might not speed up using Modin. You might have to modify it in some way. So then you can utilize Modin. Alright, so that's it for this tutorial. If you have any doubts or any questions, then please feel free to let me know in the comment section.